Hello, my name is Usana Tuntoolavest. I'm an associate professor at the Department of Electrical Engineering, เกษตรศาสตร์ University. This is a pilot class in the digital 24 hours program at เกษตรศาสตร์ University. And this class is 01-205-327, Data Communications and Network 1. Okay. So this class is intended for the third year or junior students in electrical engineering. However, there is no prerequisite, so I will try to limit the number of formulas, okay, mathematicals that I use in this class. So anyone interested can try to study this class too. Okay. Now let's introduce the website that I'm going to use. If you are เกษตรศาสตร์ university students, you can get into the EduFarm program, okay, which is the KU learning farm. This one will have the course material, okay, and the website is the, can you see, IMS. The website is ims.ku.ac.th. Okay, so you can use your non-SIV account to get into this website, and then you can select 01-205-327 class, and my class material will be in here. Okay, now let's see if I log into this. Okay. So this is data communications class, and I will post the materials here, okay, all the lecture notes here, and I will also show it in the video tape too. So if you are not เกษตรศาสตร์ University students, you can also follow along from the video tape. Okay. The first one is syllabus. So this one is for the first semester of 2016. And this is the course description. Basically, we will talk about the basic of data communications and network. Okay, the overview, the layer network architectures. We'll talk from point-to-point protocols and links and then continue to the network. Okay, we'll talk about the transmission, both digital and analog. Then we'll talk about multiplexing, switching, data link layers, error detection, and error corrections. Also flow control, okay? Then we'll go to the network, which is the wide area network or WAN, and the local area network or LAN that you may have heard about, okay? And then at the end is the internet. This is the objective of my class. So you can see that it's very specific, okay? That students should be able to first explain the layer concept. So you will learn in a bit, okay? What is the layer concept? And also compare the difference between the point-to-point and the WAN and LAN systems, okay? The second one is that you have to be able to compare and identify the characteristics of different schemes in the physical, data link, and network layer. You have to be able to solve problems in data communications and network, okay, with the learned concept and formulas, which means that you have to apply what you have learned here to solve the problem. Okay? You should be able to apply prior knowledge to develop new techniques and show ability to conduct research, okay, about recent innovations. In the actual class, we will have the project at the end about the innovations. And last year, this was very interesting. Okay? And also, this class will be taught in English, okay, so you have to understand assessment in the English language. The overview of this class, okay, first, the outline, okay, start with the overview, which we will talk about it today. And then the second one is the data communications, which is kind of the signals, okay, from the signals and from what happened in the channels, okay, the transmission impairments and the encoding, the modulation, and the data link layer, okay, the flow and error control, okay, the data link control, and multiplexing. And then we'll go to the wide area network, okay, which is a circuit and packet switching, ATM, which is not a machine to get the money, but a synchronous transfer mode, and routing. Then we go to the local area networks or LAN, okay. So we have actually what we are using right now is mostly Ethernet, but we will touch on the other topic a little bit, okay. And then we go to the Internet and Transport Protocols, which is a TCP/IP, okay, that you may have heard about. And then we go to the internetworking, which we probably gonna talk about a little bit about congestion control. Now for the teaching techniques, this year it will be different, okay, because I will try to do flipped learning. Okay, so for flipped learning, you have to watch the video first before coming to class, and then we will do activities in class. Okay, we will do like group activities, or maybe we can have a quiz or something in class. So you have to attend the class too. Okay, but please watch the video first. So I will give you lectures. Will give you homework. And the field trip is quite definite that we'll go to the satellite Earth station, okay, in Ksat University, which is very close to here, to this building. And almost every year we do an innovative subject, okay, project of what's gonna happen in the future, okay. And we'll talk about that later. The course material is in this website, as I told you before. We will have the video which I will put on the website. Okay, we have the textbook and the lecture note. Let me show you the textbook. Okay, these are the textbook. Sorry. Okay, this is the first one. It's the Data and Computer Communications 10th edition, okay, 2014, by William Stallings. Okay, this is international edition. So if you are in Thailand, okay, or you're not, I mean, you can use international edition. You can use this one. But if not, you have to use the original, the hardcover edition. Then I'm not sure what edition it is. And this is another one is by Rosen. Okay. So this is communications and networking. Okay, by Rosen, printed by McGraw-Hill, also in international edition. This is the 4th edition, which is 2002. Okay. So I will use the pictures and content. Okay, mostly from William Stallings, and some of them by from Rosen. Let's go back to this. Okay. Now for the assessment method, we will have, since this year we will do it a little bit different, okay? So the percent is not fixed yet, okay? It can be adjustable. So we have a project, we have homework, a quiz, and attendance, midterm and final. Assessment is similar, okay? We cut by the curve and some of the criteria reference. This is my office hours at Ksat University for this semester. And my room, okay? 602/3 on the 6th floor of the Suchat Kampu building. My email address. And my phone number at the office. Okay, so this is the text. The textbook that I just showed you, okay, the cover. So this one is the information. Oh, actually, sorry. Rosen has also the 5th edition 2013, but that picture was a little bit old. Okay, so you can get the 2013 book too. Okay, but this one is just a supplement. This is a class activities. Actually, we just cover the basically we just cover the topic that we just talked about. Okay, and this is the the room, the classroom. Now let's go to the materials. Okay. Okay, let's use, go to the first lecture. Okay, chapter 1, introduction, okay? What is data communications? Okay. Data communications are the exchange of data between two devices from via some form of transmission medium, such as a wire cable. Okay, so you have two devices, and they have to somehow talk together. So you have two devices here, whatever it is, and they talk together. Okay, so that's communications, and this one has to be data. Okay, if there is something that no one wants to send, have no meaning, okay? It's not communications, but they have to have something that has meaning, okay? Which is the data can be voice or image or video or just the binary data, text data, okay? And now what is data? Data refers to, actually data is plural, okay? So data refers to information represented in whatever form is agreed upon by the parties creating and using the data. What is that? Is that suppose we can think about it this way. I have an information about this class to tell you, okay? But I cannot just send the information in my head to your head, okay? We cannot do that. So I have to use some form of language, okay? And if I agree with you, okay, that if we agree that we will use English language, then that's what we are doing now. In some other class, the teacher may agree to use Thai language. Okay, so that is the form of the alphabet, the words in Thai. Okay, that will be used to represent the information that the teacher actually want to tell you. Okay, so in terms of computers, okay, you have to agree on. Like for example, if 5 volt is 1, bit 1, if 0 volt is bit 0, something like that, okay? So if both of you, both of the device know about this format, okay, they can talk together, but if at the end it doesn't know, okay? It doesn't know that 5 volt is equal to 1, to bit 1, and 0 volt equal to bit 0, it may be confused, okay? It may think that 5 volt is equal to 0 and 0 volt equal to 1, okay? So if they no agree upon a format, okay, there will be problems. Okay, now if we look at the trends of the data communications today, okay, everyone wants it to be faster, okay, and cheaper too. And also more intelligent, which means that we have a better quality of service, okay? And we have heard for a few years now that everything is like Internet of Things, okay? Or everything over IP. What is that? What is Internet of Things? Internet of Things means that you have not only that everyone has maybe like one personal device, for example, a tablet or an iPhone to have an IP, but everything around you will have IP. For example, this visualizer will have IP address. At your home, at the smart home, you can have like refrigerator can be like have an IP address, okay? And if the eggs inside of it is run out of the eggs, okay, inside of the refrigerator, it can send signal to the store, to the supermarket or something, okay, that I want to order eggs and pork, 1 kilogram or something, and then the supermarket will send someone to send you the food that you want, okay. So you don't have to order it by yourself. You can set a program, okay, that if this one is run out or you want eggs like maybe like half a dozen all the time, okay. If it's less than at least half a dozen. If it's less than half a dozen, then the refrigerator should order the new set of eggs for you, something like that, okay. And for other like electronic device, like the light when you come into your room, okay, and they have the light sensor, okay. So you come in the room, and then the light just turn on, okay. And sometimes it's just turn radio on, something like that. Okay. Now, users also want mobility, okay. So we want iPhone, we want Android. Okay, we can have Android in like other, that is not Apple, okay. So other company like I use Sony, okay, and you can have Samsung, Sony, okay. And they have iPad, okay, and tablet, okay. You can use cloud computing, so you don't have to keep the data in your device. You can put it in the cloud, and then whenever you want to use it, you can take it, okay. And this is the simple, okay. The line is not clear, but there's line connecting every box. You can see that this is the most simple, the simplest communication system models, okay. We have a source. The source can be, for example, me, I'm talking, okay. So the source can be my voice or my image, okay, or if I'm moving the video, okay, and then send to the transmitter, okay. So the transmitter will change my voice or whatever, like the image or the video, okay, into the form that can be transmitted through the transmission system, okay. And the transmission system can be anything, can be only one link, okay, from point to point, or it can be a network, okay. And then at the end, the received signal will go to the receiver. The receiver will convert the received signal, okay, that it receives maybe from, if it's wireless, it may receive from an antenna. If it's a wire cable, it's received from the cable, okay. And if you convert this one or interpret, okay, what the data is, okay, depend on whether it's digital or analog, okay. If it's digital, it's like, it can be think of as interpret the data into the image or the data or the bit sequence or the video, okay, that we want, and then send to the destination, which is you, okay. You are the destination that is watching the video, okay. And this is an example in a more pictorial form. You have the workstation sending to the network, okay. So we don't know what the network is working, okay. The user doesn't know. The network will send to the correct destination, okay. But we will learn in this class what the network is doing. This is a more detailed model, okay, of the data communications system model, okay, with signals. You can see that at first, if you have text, okay, you want to send, for example, you want to send data communication and network, okay, just lecture note, okay, for example, in the text form. Then first, we'll look at it as the number one, okay, in the circle here. This is input information M, okay. We use the variable M, and then so this is the source, okay. The source sending out. So the text that for example, you input A, B, C, D in the computer, okay. What happened is that it will change into like digital bit stream, okay. And this one in the digital bit stream is the input data. The number 2, we can think of this as GT, okay, which is a function of time. because it's a signal now. And then you go to the transmitter will send it to the transmission system. If the transmission system, okay, usually the transmission system requires analog signal, but sometimes not, okay. If it's fiber optics, then you can send like two state, okay, have light or doesn't have light, okay. So light or dark in fiber optics. So this after the transmitter, it can be also digital signal. But usually, if you send it through the air or to the other cables, usually they are analog signal, okay, so that they can transmit through that medium. Then when you receive it, the transmitted signal is ST, okay. So it's different from GT, so it's also a function of time, okay. And then when you go to the transmission system, you receive an analog signal here. If you send analog signal, you receive analog signal, okay. Then you have a receive signal RT, okay, which is a function of T. Then you send to the receiver. The receiver will read it, okay, will receive this one and then change it or interpret it or convert it, okay, into the digital bit stream, okay, which is number 5. Number 5 is output data, which is G prime T, okay. You can see that. Okay, so there's DT and then there's G prime T, okay. So this is the input data and this is the output data. This has a G prime because this one and this one may not be equal, okay, may not be equal because they may have some errors during the transmission. And you have M as the input information. You will receive M prime, okay, as the output information. Again, the M prime and M may not be equal, and that's why there's different parameters. But we try to make it equal, okay, as best as possible. As an engineer, communications engineer, we want to make this one the same. Okay. So if you get the same, okay, you have the same text as what you were sending. Okay, and this is again the line is not clear, but there's a line connecting, with the arrows. This is some of the more detailed, okay, box inside of the system. Okay, we may have all of this, or maybe we have some of this, or we may have more than this. Okay, when you study more and more, there will be more and more box inside of the system. Let's see an example. Okay, you have source coming in. What is A to D? A to D is analog to digital conversion. Okay, so if you have an analog signal coming in, and then you change it to digital signal, okay? So this is A to D. But if your signal is already digital, you don't have to do this, okay? So you don't have to do A to D if your data is already digital. And we have the data compression, okay? Data compression is that if you have a lot of data, okay, and you want to make it less, okay? We will talk about this later. But basically, if you have a lot of data coming in, okay, let's say 1,000 bits, and you want to make it less, okay? Let's say you want to make it 500 bits, okay? Sometimes you can do this, sometimes you cannot do this, okay? Depend on the information inside of the data of the bit sequence, okay? So sometimes you can compress a lot, sometimes you can compress less, okay? And we will talk about the techniques for compression in a little bit more. Then there's data formatting. Okay, the data formatting is that, as I said before, if you do like 5 volt, okay, 0 volt, you say this is equal to 1. This is equal to bit 0. Okay, so this is data formatting. Again, we will learn about this later too. Then we have the data framing and packetizing. Data framing is that if you have the sequence coming in here, okay, when you do framing is that you take the data, part of the data, okay, so you take part of the data here, and then you put header in front of this. Okay, so this is equal to a frame or a packet. Now we have the adding header. Okay, adding header as I was telling you before, the frame and the packet, okay, it's actually similar, but usually the frame is at the second layer of the OSI model, which we'll talk about layer concept later. Okay, packetizing is like packet is like in a different layer, in the third layer. Okay, we'll talk about that later. What is the second layer? What is the third layer? Next is modulation. Okay, so for the modulation, the modulator here, actually if it's a block, we can look at it as, we can call it a modulator. But this one we call it like kind of the action, okay, that we are just doing. Okay, so the modulator here will change the bit, okay, in the packet, okay, into electromagnetic signals that can transmit through the links, okay, which can be 1 link, 2 links, okay, many links, or it can be a network, okay, and these signals, okay, is such that it can be transmitted via the air or through the transmission medium such as cable, okay, or fiber optics, like. And it depends, okay, it depends on the size of the antenna, okay, and it depends on so since we haven't talked about the behavior of different frequency signals yet, okay, so I will just talk only a little bit here that if you want to send wireless, okay, using antenna, you have to use high frequency, okay, megahertz, 100 megahertz, for example. If you use voice signal, we cannot transmit through the antenna. We cannot use it for in practical purpose, okay, because the antenna will be very big. Anyway, when you receive the electromagnetic signal, okay, through that you receive, okay, to the demodulator. Again, demodulation is like the action, okay. So this one, you can notice that whatever you do at the transmitter is the first, the upper box here, okay, and the receiver is the lower box here. You can see that whatever you do at the transmitter, you have to cancel it, okay, or you have to reverse the action at the receiver. So if you do modulation there at the transmitter, you have to demod at the receiver, okay. If you do framing or packetizing, you have to do depacketizing. Depacketizing means that you take the data back, okay. Suppose this is a packet, right? So when you go to the depacketizing, okay, what happens is that you will take the, okay, you take the header out, okay, so no header anymore, okay, just this box, which is the data. So depacketizing means that you take the header out, and sometime in the header they will have in the header here, this box here, they will have like many bits, okay, and some of these will be used, okay, some of the bits here will be used for error correction. Or error detection. So when you depacketizing by you take the header out, you not just throw it away, okay? You have to read at the header, okay? What is the destination, what is the format, information inside of the header, and also if you have the error control in here, like the error correction or error detection, then you can use this to check whether the received data is correct or not, okay? You can check whether this is correct or not by using the bits here. So that's why I say that put it here that is error detection and error correction, okay? After this, you have a bit binary sequence. And if you have to interpret the data. If you have compressed the data, okay? If you compress, like if you have 1,000 bits and then you put it to 500 bits here, okay? By doing the compression, okay? So you have to take it back to 1,000 bits. This is the decompression. Okay, to get the original back. So this is equal, okay? But this is what transmit. This one is transmitted, okay, which is less than the data, okay? Because we want to save the money, okay? We want to use the resource as little as possible. Sometimes if the file is too big, you cannot attach to the email, something like that, okay? Then you have to compress it. Okay, then send to the destination. Now, we will talk about the communication text, okay? This is like the overview of what we have to do to make communications, data communications success, okay? The first thing is that we want to be efficient. Efficient means that we want to send as little as possible by doing data compression, okay? If you can send with 100 bits, okay? You shouldn't send more than that, okay? Because if you send more, you have to pay more, okay? To use the resource, you have to, if you are an engineer, you have to design, the resource, okay, or the bandwidth for the users more, okay? If it's not efficient, okay? So if it's not necessary, you don't have to send. And we will talk a little bit about the techniques on the data compression. The second one is that we have to do the interfacing, okay? The interfacing is between device and transmission system. If you look at your device, okay, when you want to, like I'm connecting my iPad, okay, to the monitor or to the camera, okay? So I have to have kind of a plug, okay, or an interface, okay, to plug in, okay, to link between my device and another device. This is interfacing, okay, hardware interfacing. We have the third one is that we have to do signal generation, okay, which is the signal have to be able to propagate, which means that it has to be able to travel through air or through the wire, okay? And it has to be able to interpretable as data. So when the receiver look at it, okay? If there is no noise, no problem at all, okay? Look at the signal. The one who look at it has to be able to know what it means, okay? Just for example, if you look at this, okay, using this one, this is 5 volt, okay, this is 0 volt. So you have to be able to implement this as 1, 0, 1, 0, 1, 1, okay? So this is how we interpret the data. The fourth item is that we have to do synchronization. Synchronization is a big problem, okay? And I don't think we have much time to cover it in this class. However, we do the simple synchronization, okay? The synchronization is that we have to sync between, we have to know, okay, when is the starting of the signal, when is the ending of the signal, okay? So that the receiver can understand, okay, can correctly interpret the data, okay? And there are several levels of synchronization. We have to synchronize in terms of bit or character. Character is like A, B, C, D, okay? So one alphabet, something like that. Frame, okay? So every block of frame, okay, you have to synchronize what is the start and ending of frame. When is the start and ending of the bit? When is the start and end of the message, okay? Message means that there's a lot of message. For example, in this taping, the message starts at the beginning, okay? At whatever time that we start recording, okay? And we have to know the phase of the synchronized sinusoidal carrier, okay? So if you use sinusoidal carrier signal, okay, as a carrier, you have to know sometimes the information is inside of the phase. So if it's not synced, okay, you have a problem in understanding what the sender is sending to you. Okay, for example, if this is the data, okay, the data start, let's say this frame start here, okay. Now, if the receiver is confused and is not synced and is think that the frame start here, okay, it will think that the frame start here, okay, because the timing, this is the time, okay, so the time is not synced, so this one will be wrong, okay, this frame will be wrong because the correct frame is actually start at this point. The fifth one is the exchange management, okay? We can do the full and half duplex, okay? We can design whether it's full duplex or half duplex. What I'm doing now is like half duplex, okay? Because I'm sending only one way. Full duplex is like sending both ways, okay? You can, both of the user in both ends, okay? They can communicate. A can send to B and B also can send to A at the same time, okay? Actually, what I'm doing is like one-way communication. It's not even half duplex. Because half duplex, you have to be able to talk when the other stop, okay? Let's say A send to B, okay? So A keeps sending to B. When A stopped, B can send to A, okay? This is half duplex. Not sending at the same time. Okay, so half duplex is not sending at the same time, but full duplex. It's like when you make conversation, okay? When you talk, the other should listen. When the other talks, you should listen. This is kind of half duplex when you make a conversation. But full duplex is that when A send to B, B can send to A at the same time. Okay, so they can send at the same time. It's full duplex. You have to do like how to make manage to make connection and disconnection. Like when you call someone and you have to dial the number to make connection, and you hang up to disconnect. Okay, and you have to manage about the data rate. Okay, the delay. And reliability of the requirement and also the quality of service, okay? If you pay more to the service provider, then you should get a better service. 6 is the error detection and correction, okay? This one is required when errors cannot be tolerated, okay? For example, if I send you the lectures here, and if what you receive is not the same as what you are sending, what you receive is not the same, okay? Let's say you email this file or you download the file, okay? It's not the same, okay? You don't want that, right? You want the received copy to be exactly the same as the original copy. But in some applications, okay, error detection and correction is not required. For example, if you have the phone conversation, okay, if you cannot listen to the other side, if you heard, let's say there's a noisy or noise coming in and you didn't hear what the other side said, the user can ask, oh, pardon, what is it? Can you say again? Okay, so you don't have to, the system doesn't have to do the error detection correction for the user. User can do it by themselves, okay? Flow control, okay? Flow control is, okay, sometimes you send, the source send, okay, if it's too fast, okay, it's sent with a higher data rate than what the receiver can receive, okay, then some of the data will be lost. So you have to control the flow, okay? What I'm doing here is that I'm videotaping the class so that students, previous students, they usually told me that I talk too fast, okay? So you can listen to it again, okay? You can control the rate, okay, of the video tape. But if I'm in the class, you cannot control my rate, okay? Except that you ask me, okay, please slow down. But then I will speed up again in a while, okay? Because usually I talk fast. Anyway, I will talk slower. 8, addressing and routing. This one is needed for multi-user situation, okay? So if you want to send, for example, think of it as the mail, okay? The snail mail that's sent with a mailman, okay? So there are many packages or many envelopes, right? So the envelopes have to have the data. The envelope has to have, to someone, means, okay, and address, okay, here, and from someone, okay? So this is the address. Because the mailman will have a lot of, in his bag, okay? There's a lot of envelope and package inside, okay? So everyone have different address, so the mailman can send to the correct destination. But if there's no address, they cannot send, right? Okay. But this is not needed if there is one-to-one. If you make conversation or you send to only one link, okay? If you send from this to this, okay? Just one link, okay? Then you know that whatever you send have to go to this person. Then you don't need to have an address. 9, recovery from network and link faults. If there's something happened, okay, and the network is down, then you have to know what is the procedure, okay, to follow when there is a fault occur, okay, during the transmission. Change formatting, as I have talked before, to interpret the data. So you have to know the data formatting, okay. 11 is security, okay, authentication, which will not be covered in this class. But authentication is to make sure that the owner, okay, the real user, access that information. For example, we can use username and password, okay? And right now they want the password to be long, okay, and have alphabet and also numbers and also special alphabet, something like that, special characters, okay? This one is to provide privacy to the users. Network management is to monitor the status, okay? If you work in the company service provider, you have to have an engineer to monitor the status, to react to failures, and also to do the network planning.